Everyone is talking about big data, but what actually makes a data set big? And in agriculture research, do we really deal with big data or it is just a big confusion? Let's break it down. Having thousands of samples or millions of rows in your spreadsheet does not make it big. It is a well organized and a well structured data which can be easily handled by R or even Python. Big data starts when your system says, I can't handle it anymore. That's where Spark, Hadoop, and cloud analytics steps in. Also, big data is not determined by a specific number of observations or gigabytes. A data which actually challenges our ability to store, manage, and analyze it efficiently is considered as big data. A true big data comes with 5 V's: volume, velocity, variety, veracity, and value. In agriculture research, true big data comes from satellites, IoT sensors, genomic data. Most of the master's research, most of the doctoral research, and most of the research works which we used to do or projects which we used to do, they are not big data. They are well organized data sets. So stop calling every spreadsheet big data. It's like calling a pond an ocean. And here is we often go wrong. Statistical models are outdated. They're replaced by machine learning algorithms to tackle big data. It's not like that. Machine learning algorithms are based on statistical principles. Every algorithm, whether it's support vector machine, whether it is random forest, whether it's neural network, it's based on statistical logic. It's sampling techniques which actually decides which data will enter in your algorithm. It's probability which drives the prediction, and even its bias variance trade-off which still rules the learning. Because in agriculture research, we don't just need predictions. We need to understand why yield change. We need to understand why yield drop. We need to understand which varieties are different. We need to understand why breeds are different. We need to understand why nutrients shift. We need to understand why rainfall matters. That's why statistical thinking gives meaning to the big data. So remember, big data increases your capacity, statistics gives direction. Without statistics, big data is just blind data.